Hello Math 119 students. So this video is a supplemental video for section 5.4. So Hawk's Learning System, when they discuss section 5.4, they base everything on this formula here. But I'm going to do an example, and I'm not going to use the formula at all. You really don't need to use this formula. So here's the first example. I want to redo this problem we did from chapter 4. This was one of the first examples for probability that we did from chapter 4. So here's the problem. We had 2 red marbles and 3 green marbles, and we select 2 of the marbles from the bowl. And then we want to calculate the probability that we get 2 marbles of the same color. So for this example, I will calculate the probability of selecting 2 green marbles. So here are the 5 marbles we have in the bowl. I have them labeled. 2 reds and 3 greens. So the number of ways you can select the 2 marbles from these 5, I have listed in the sample space all the possible outcomes. So there's 10 ways you can select 2 marbles from the 5 marbles. So then the way you can figure out the answer for the probability of selecting 2 green is simply by counting. We have 10 possible outcomes, and then we count the number of outcomes in which we select 2 green. So that would be 3 out of 10. So that should be our answer. The probability of selecting 2 green marbles would be 3 out of 10. Okay, so now this is a typical problem that you would get from section 5.4. So now I'm going to solve this problem using the hypergeometric distribution. So with the hypergeometric distribution, the formula for the hypergeometric distribution, we have 3 C's. So what is let's do the denominator C first. So what the denominator C does is it counts the number of outcomes. So with the denominator C, we have 5 balls, and we're selecting 2 balls. So the denominator is 5C2. Well, it just so happens that 5C2 is equal to 10. And 10 is the number of outcomes in the sample space. So that's what the denominator in the hypergeometric does. It counts the total number of outcomes in the sample space. Okay, now we have to figure out the numerator. So with the numerator, we have 5 balls, and it consists of 2 red and 3 green. So notice 2 plus 3 equals 5. Okay, so the C that has the 3 in front. Okay, so that's the 3 is the number of green. So we want to select 2 green from 3. So how many ways can you select 2 green from 3? That would be 3C2. And that just so happens equals 3. And 3 is the number of outcomes in the sample space that has 2 green. Okay, and then the C with the 2 in front, 2 represents the number of red. Well, we're selecting 2 green and 0 red, so it would be 2C0. And it so happens that 2C0 is 1. So what this tells us really is that there's only one way you can select 0 red from 2. Now, if we calculate the fraction, 1 times 3 is 3, and the denominator is 10. So we get 3 out of 10. Okay, so we just solved this elementary problem from chapter 4, but we used the hypergeometric distribution for this one. So now let's do a more typical problem that you would get in the chapter 5.4 homework. So let's say we have 4 red marbles and 6 green marbles, and we're going to select 3 marbles. So now we're going to use the hypergeometric probability for examples A and B. So A says we want to find the probability we select 1 red marble and 2 green marbles. Okay, so let's make our 3 C's. So we have a total of 10 marbles, and we're selecting 3. So the denominator will be 10 C3. So if we listed all the possible outcomes in the sample space, this is how many outcomes we would have. So 10 C3, I'll use my calculator. So I'll calculate it with the calculator. 10 C3. $120. So our denominator is 120. Okay, then for the numerator, our 10 balls consist of 4 red and 6 green. Okay, and then we want to select 1 of the 4 red. So the number of ways we can select 1 red from 4 is 4C1. And then we want to select 2 of the 6 green. So the number of ways we can select 2 green from 6 is 6C2. Okay, it so happens that 4C1 is 4 and 6C2, I know what that is without using the calculator. It's 15. So the answer is 4 times 15 is 60 over 120, which reduces to 1/2. So that's the answer for part B. Now a typical problem you might get on the homework might be to answer this question. What's the probability of selecting 2 or more green marbles? Okay, so in part B we found the probability we selected 2 green marbles. So but the probability of selecting 2 or more green marbles would be the probability that we get 2 green. The other possibility is we could get, with 3 selections, we could select 3 green also. Okay, so the probability of selecting 2 green, we already calculated that from part A, that's 1/2. So now let's calculate the probability that we select 3 green out of 3 selections. So the denominator, for these problems, the denominator will remain 10C3. But now we need to figure out how many ways can we select 3 green from the 6 green. So actually, if we compare this to part A, we will still have 4 and 6, just like we had for part A. So in front of the 2 C's we'll have 4 because we still have 4 red and 6 green. What will change is, in part A, the second numbers were 1 and 2. The second numbers will change when we select 3 green. So now we're selecting, out of the 6 green, we're selecting 3. And out of the 4 red, we're selecting 0. Okay, so let's calculate the second part. So 10C3 is still 120. For anything C0 is 1. And then 6C3, let me see what that is. $63, I computed it with my calculator, is 20. So we will get 1/2 plus 20 over 120. Well, 20 over 120 reduces to 2 over 12, which reduces to 1 over 6. Okay, so we will get 1/2 plus 1/6, which is 3/6 plus 1/6, which is 4/6, which is 2/3, 4.67. So I hope this is helpful for you. There's an example of a typical homework problem from section 5.4 that you might encounter. And you notice I didn't really look up what the formula was. I didn't use the formula that they give you in section 5.4 of Hawks. So anyway, I hope that's helpful. And if you have any questions, we can go over it either office hour or during the Zoom meetings.